Hi, I'm Mr. Rich. There is more than one way to solve problems in mathematics. I'm going to show you how we can solve word problems involving fractions with unrelated denominators using the bar model method, a method that children in Singapore use. Singapore is a country in Asia, about 8 hours by plane away from Brisbane. To add structure to the way we solve the problems, we use a 4-step process: understand, plan, do, check, first shown to us way back in 1945 by the Hungarian mathematician George Polya. Let's explore how to use the bar model and the 4-step problem-solving method by looking at a word problem involving fractions where the denominators are unrelated. The first step in solving the problem is to understand the problem. Harry, Hermione and Ron had 216 stickers altogether. Harry gave 3/10 of his stickers to Hermione and 1/4 of his stickers to Ron. After that, all 3 children had the same number of stickers. So the children didn't have the same number of stickers at first, but they did have the same number at the end. Harry must have had the most stickers at first because he gave some fraction of them away. He gave away 3/10 to Hermione and 1/4 to Ron. We want to find out who had more stickers initially between Hermione and Ron, and how many more, and how many Harry had initially. We've completed the first step. We understand the problem. In the second step of problem solving, we plan our solution. The quantities in our example are related, and they can be represented using bar models. Bar models are used as a way to help organize information in a problem into a diagram to help us to see how to solve it. The lengths of the bars represent the sizes of the quantities in the problem. We represent the initial number of Harry's stickers as the whole amount in a part-whole model. We don't know the exact number of stickers he had yet, but we can draw a bar to represent the total number. This bar is first divided into 10 parts because we know that Harry gives a number of tenths to Hermione. He gives 3/10. We divide each tenth into 2 parts. The bar now has 20 parts altogether to show the number of quarters that Harry gives to Ron. Harry gives Ron 1/4 of his stickers. We draw another bar model, a comparison bar model, to represent the different number of stickers each child has. We draw the bars representing the number of stickers all 3 children had after Harry gave some stickers to Ron and Hermione. All 3 children ended up with the same number of stickers. We have completed the second step. We have a plan for solving the problem. The third step in problem solving is to do. Creating a unit to represent a number of items in a problem can be helpful. Here, each unit represents a number of stickers. We develop our answer by looking at the total number of units the children had at first. Harry had 20 units, Hermione had 3 units, and Ron had 4 units. In total, there is 27 units. 27 units equals 216 stickers. So 1 unit equals 216 divided by 27 equals 8 stickers. We can see from the model that Ron had 1 unit more than Hermione at first, so he had 8 more stickers. Harry had 20 units at first. 20 times 8 equals 160. So Harry had 160 stickers at first. The fourth step is to check your answer, and we can do this by substituting the numbers into Harry's part-whole model. Harry had 160 stickers. He gave 3/10 to Hermione, which is 3 times 16 equals 48, and 1/4 to Ron, which is 40, leaving him with 160 minus 48 minus 40 equals 72 stickers. 72 times 3 equals 216, the number of stickers Harry, Hermione and Ron had altogether. So because the problem conditions have been met, we have checked that our answer is correct. We've just used Polya's 4 steps of problem solving: understand, plan, do, check. Combined with the bar model method, we have a structured approach to solving word problems involving fractions. We use 2 types of bar models: a part-whole model for Harry's stickers at the start, and a comparison model to show all 3 children's stickers at the end. Let's use this approach looking at another example. Liv and Maddie bought some roses and daisies. They each bought the same total number of flowers. The number of Liv's roses was 2/3 the number of Maddie's roses. The number of Maddie's daisies was 1/2 the number of Liv's daisies. Liv was left with 1/4 of her roses after she gave 6 roses to Parker. After Maddie gave some of her daisies to Liv, Liv had 5 times as many daisies as Maddie. The first step is to understand the problem. Let's analyze the quantities given in the word problem. We do not know the number of roses and the number of daisies each girl bought at first. What we do know about the number of roses and daisies at first is that the number of Liv's roses was 2/3 the number of Maddie's roses. We also know that the number of Maddie's daisies was 1/2 the number of Liv's daisies. Did the number of roses that Liv have change? Yes, she gave some of her roses to Parker. Note how other information is given as a fraction, but this is an absolute number of flowers, 6. Did the number of roses Maddie have change? No, we don't have any information on this, so we must assume no change. Did the number of daisies Liv have changed in the end? Yes, Liv had more daisies because Maddie gave some to her. We want to find out how many roses and daisies Liv and Maddie bought initially, the fraction of her own daisies that Maddie gave to Liv, and also what fraction of Maddie's flowers at the end were daisies. We've completed the first step. We understand the problem. Step 2. We plan a solution. We can select bar models to represent the information. We first draw the part-whole models for Liv and Maddie, factoring in the comparisons between the number of roses and the number of daisies between the two girls. Liv has 2/3 the roses of Maddie, and Maddie has 1/2 the daisies of Liv. Because each girl has the same total number of flowers at first, roses plus daisies, the bars begin at the same length. From the number of roses Liv gave Parker, we can determine the size of one unit. 1/4 of the number of roses Liv had to start with is the most appropriate unit because all of the gifts of flowers are equal to or multiples of that unit. We can represent the before and after changes in quantities of roses and daisies between the two girls in the model by creating a comparison model and showing the changes in the length of the respective bars and subdivisions. Liv gives 6 roses away to Parker, leaving her with 1/4 of the roses she started with. We divide Liv's roses into quarters so we can give 3/4 away. We give part of Maddie's daisies away to Liv. Keep in mind that Liv will have 5 times as many as Maddie once the exchange occurs. We use a change bar model for this. We now have a plan to solve the problem. We've shown that both girls had the same number of flowers at the start, that Liv had 2/3 the roses of Maddie, that Maddie had half the daisies of Liv. We then showed that Liv gave 3/4 of her roses to Parker, and Liv ended up with 5 times the daisies as Maddie after Maddie gave some of her daisies to Liv. Step 3 is do. Solve the problem mathematically. From Liv's exchange with Parker, we see that 3 units equals 6 flowers. 1 unit equals 6 divided by 3 equals 2 flowers. At first, Liv had 4 times 2 flowers equals 8 roses, and 4 times 2 flowers equals 8 daisies. At first, Maddie had 6 times 2 flowers equals 12 roses, and 2 times 2 flowers equals 4 daisies. The model shows us that Maddie gave away half of her daisies to Liv. In the end, Maddie was left with 7 units, and just 1 unit was daisies, so Maddie's daisies were 1/7 of her total flowers. Step 4 is to check our answer. We must always check that our answers make sense by substituting the values back into the original fractions given in the problem. Did Liv have 2/3 the roses of Maddie? Yes. Liv had 8 and Maddie had 12. Did Maddie have half the daisies as Liv? Yes. Maddie had 4 and Liv had 8. So again, we have used Polly's 4 steps of problem solving, understand, plan, do, check, and the bar model method for a structured approach to solving word problems involving fractions. This problem required the use of the part-whole model to represent the number of roses and daisies each girl had, the comparison model to compare the number of roses and daisies between each girl, and the change model to represent the before-after scenarios of the number of flowers each girl had at first and then at the end. What observations did you make? Try and make a word problem involving fractions yourself and show a friend how you can solve it using the bar model and 4 steps method.